Welcome back to my channel. I want to do a video about math. A relationship in math is a collection of pairs of objects from two sets. A function is a rule which takes objects from a set and assigns exactly one output from another set. So an example of a relationship would be like parents and their children. Another one would be U.S. citizens and their social security numbers. The parents and their children is not a function, but the people in the social security number is a function, because a parent could have a lot of different children, so there's a lot of different outputs that correlate to that input. And a U.S. citizen has one unique social security number. So I want to do an example of a problem involving this concept. It's from a book, this book. So I guess I should probably give credit to these people. So the problem says the distance between Cambridge and Wellesley is 10 miles. A person walks part of the way at 5 miles per hour, then jogs the rest of the way at 8 miles per hour. Find a formula that expresses the total amount of time for the trip. T of D as a function of D. And D is the distance walked versus the distance jogged. So you have the city, Cambridge and Wellesley, they're 10 miles apart. The guy walks at 5 miles per hour, and he can also jog at 8 miles per hour. His hat's getting blown back there. And they say find the time to get from Cambridge to Wellesley as a function of the distance walked, or the portion of it that he walked. Okay, so first I want to talk about how we're going to think about this. So first we want to talk about how we figure out the time taken to travel a distance at a given speed. So if you have 10 miles as a distance and you're traveling at 5 miles m per / hour h, the way to think of it is kind of basically common sense. Well, 5 miles per hour just means you're traveling 5 miles. It takes an hour to go 5 miles. So if you want to go 10 miles, it's going to take 2 hours. So that's basically just division is what we did there. And so dividing these numbers gives you 2, but the units of miles and miles per hour should be divided too, so should be taken into account. And so basically miles over miles, it's just kind of handled like numbers. That's just cancels out. A mile divided by a mile is 1. But then you're dividing, or you're multiplying these by basically 1 over h, which is the same as multiplying this whole fraction by h over 1, which just leaves you with 2h, or 2 hours. And so the same, can I kneel down? Okay. The same thing is, so you can just, to show as an example, if you went 5 miles at 5 miles per hour, well, obviously that takes 1 hour. And so you could rewrite that as these cancel out. This 5 over 5 times 1 over h equals 5 over 5 times h minus 1, because that was just the denominator being multiplied by that fraction, equals 1 hour. Okay, so now we want to find time to get from C to W as a function of D, distance walked, and they told us to use T of D, which is makes sense. So T of D When you first think about it, it's kind of like head scratch. But when we're looking at, well, how long does it take to go a certain distance? Well, we basically were just dealing with that concept, like the you know, we had like 10 over 5 miles over miles per hour, but they want it to be as a function of d. So you could plug in any distance, and so our distance is going to just be d, and then we know that, and d is distance walked, which we know the walking speed is 5 miles per hour. And we already did all that. You know, so this is going to be miles and this is going to be miles per hour. And we already worked out those units, how they cancel out and just become, the answer is in the unit of time, which in this case is hours. So that tells us, okay, how long does it take to go d miles at a rate of 5 miles per hour? But the other thing they're throwing at us is, well, he may jog some of it. So he might jog none of it. He might jog half of it. So what if he did jog some of it? Well, it's going to change this equation. So we know it's 10 total miles to get from Cambridge to Wellesley. And so if he's walked d miles, well, the rest, and he jogs whatever distance he walks, the remainder of that distance that he jogs is 10 minus the d that he's already walked. But the time it takes to do that, like we showed before, is divided by the speed, which, well, when he's jogging, it's 8, and his hat blows back. And so that is the answer to the question. And if he went distance walked was 10 the whole way, if he walked the entire 10 miles, you'd have 10 divided by 5, which is 2, plus 10 minus 10 over 8, which would be 0 over 8, which is 0. So you'd have 2. So that kind of proves that formula works for that, and you can plug in other distances walked to get the correct answer.